Hi everyone, thanks for joining. My name is Abdul Rahman and I'm a steering committee member at ACE and stream owner for IoT and its security. ACE is a global community of industry practitioners and researchers who have gathered around topics in emerging technologies, including AI, machine learning, IoT, edge computing, and cybersecurity, to discuss the latest research, industry practices, and products. We have a repository of YouTube videos of researchers and industry practitioners presenting and showcasing their research and industry practices and trends on AI, machine learning, blockchain, and IoT. We also host social events where you can get a chance to interact with the fellow community members. We conduct workshops on emerging and hot topics in technology that help participants get up to speed with the area. Uh, Currently, we have some really exciting, excellent workshops on AI and machine learning that cover the complete spectrum from the foundational theory of machine learning to ML ops and deploying machine learning models in production. We have multiple streams organized around specific topics, including natural language processing, ML ops, IoT and its security, graphical neural networks, reinforcement learning, etc. Please subscribe to our YouTube channel, ML Explained AI Socratic Circles ACE, which has a repository of our current videos, and also be sure to check out our website, ai.science, to keep on top of our events. So today I'm really excited to host Mostafa from Vodafone. Mostafa is a RAN AI and data analytics distinguished engineer at Vodafone. Mostafa is a globally recognized authority in digital transformation and RAN strategy, design and optimization, and applications of AI and machine learning to innovation. He's a chairman for ITU Network 2030, co-chairman in ITU FGML 5G WG1, at CPOC reporter leader, and International Academia board member advisor. The distinguished engineers community at Vodafone consists of 15 world-class members, which includes professors and the highest standard engineering experts worldwide. The community is responsible for sharing the future of technology worldwide through research and technical consultancies. Mustafa holds a Bachelor's of Science in Electronics and Telecommunications and is undertaking Master's of Science in Nanotechnology and Artificial Intelligence. He holds 3 patents and the 4th one is in progress, and has authored and contributed to numerous publications and participation regarding AI, cognitive networks in ITU, ETSI, GSMA, besides his psychology self-study. So today, Mustafa will be talking about AI and machine learning use cases in telecom. In his talk, Mustafa will be covering applications of AI and machine learning to various use cases in telecom, including geolocation use cases, RAN self-healing, coverage prediction, power backup systems, smart capex, etc. With 5G and exponential growth in data expected from IoTs and machine-to-machine communications in a machine economy, it is exciting times for CSPs and telecoms as they will be carrying swaths of this data and can leverage advances in AI and machine learning for exciting business use cases. I will now pass it over to Mustafa so that he can talk about AI and machine learning use cases that he has been spearheading at Vodafone. Over to you, Mustafa.
Thank you, Abdurrahman. Thank you very much for this quite nice introduction. It was very, very good. Thank you very much for that. So, as you said, today I will try to illustrate some of these current use cases that we already work inside Vodafone with the community of the research, with the subject matter experts inside Vodafone, and even with some aid or some support from the ITU and ETSI and so on. So, at the talk of the today, I will talk about some slides, and then we can have the discussion that we was trying to explore more about the details and the strategy of this of Vodafone, of myself inside Vodafone regarding this topic. So the talk of today is called AI Machine Learning Toward Telecom Future. Next slide, please. So just small agenda, and I will try to be more briefing in this slide because I believe that the discussion will be much better, much richer than just putting up some slides and talk about it. So I will have to talk about the definition very fast about the AI machine learning, concept illustration, the telecom use cases, and then we can stay for the discussion and the question and answering. Next slide, please. So the AI and the concept or the whole idea of the AI is how to try to make the machine be able to carry out some task in the way that mimic the human intelligence, and we can consider it as a smart machine or a smart computer. And here is the main problem, that the definition of the smart of the human is different from one concept to another, and even it was very huge dilemma for the philosophers and this kind of psychological experts to define the intelligence of the human. Next slide. So it will be very, very nice for you if you read this book before, so you will know what I'm talking about. If you don't, you have to. I think you need to read about it. It's very, very good. It's called the Book of Why, and it talks about the causality and the cause and impact and cause and effect of everything, and everything happening for the reason and so on. So in this book, you will see a picture that it will show you that the cognition of the human, or the cognitive journey ladder of the human. So it starts with the seeing. So if you have a baby right now, or just a small kid, he will do a lot of observation without any interaction, and then he become to be a toddler and a kid and so on, and he will do some extra activities that would take him from one step to another, and the cognition, which is the interaction. So it's seeing interaction, and then the last step of the human intelligence in this illustration, which is the imagination and creativity, and you have your own strategy or your own philosophy for the ideas. So the machine is always trying to mimic these three steps in a way or another. So if you are talking about sensors and this kind of ecosystem that translates some information from one media to another, we are talking about here about the observation or the seeing. And if you do some activity or actuators for these sensors, then you are doing some doing an interaction. But the missing part here is about the imagination, how the machine can create something. And this is the next step, but maybe that we don't see it right now in the near future, even with the deep learning and quantum computing. But I believe that we are still in the middle of the interaction. So the machine is intaking some data, doing analysis, and then doing some action according to machine learning, deep learning, or even a rule-based, very basic rule-based thing. So next step, please. Next slide. And this is like a quick comparison, but how it can show you how the deepness of the human intelligence and how rich it is, and comparing to artificial intelligence. For example, I will give you something that we cannot translate into mathematics for the machine learning here. Maybe I can be like someone, but I'm hating his act and his action. So this complex feeling cannot be translated to something that can the machine mimic in the future. So the human is more intelligence, much richer than the machine learning and artificial intelligence. Next slide, please. And this is like a quick, very, very common understanding for how the machine learning. So the bigger science here is called the artificial intelligence, and then there is a subsidiary from this science is called machine learning, and there's another subset from the subset is called deep learning. And the machine learning here, you can check the types of machine learning: supervised, unsupervised, or reinforcement learning. I don't want to talk in very deep in the machine learning because it will not, maybe it will consume time. And let's jump to the idea of our talk today. Next slide, please, Abdullah. So at the old days, you are doing software engineering and you do some coding and you build up a program. So this program will have an input, and the program will have some instruction, rule-based, something like that, and then you'll have an expected output, for example. But for the machine learning, you have to let the machine train itself by inputs and some known outputs, and then the machine do this kind of correlation with different technology, and then you let this learning program inferred with another inputs, and then you have an output. And this is the difference between the machine learning and old legacy programming. Next problem, please. Next slide. And there's a lot of application about the natural language processing, speech text, and so on, predictive analytics, face recognition, a lot of things that you can apply the artificial intelligence in, and you can have a better and efficient way of doing the things. Next slide, please. So let's talk about the use cases right now, and this is the main topic, the main part of our topic today. We at the telco right now. We consider to be the bank of the data. We have a lot of data, data from the network, data from the customers, data from the ecosystem, from the partnership, and so on. So and you know that data is the core of any analytical activity. So if it's like a human analytical activity, or it's an artificial intelligence data and analytics and data science. So we have a very, very good reach content to work over it. using artificial intelligence. And today I will talk with some use cases right now. And the first one is called the geolocation use case. And from the name, you can maybe understand that we are using some geolocation information, and we can put a layering of this for some insight and KPIs over the geolocation of the map or the geolocation information, and then you can allocate a new insights from using the machine learning. For example, you have an overlap detection. In the telco, each and every cell part in the cellular network cover a small place, and it's designed to cover this place, for example, a diameter of 1 kilometer or smaller. And if you have two network that have been a lot of overlap, it will cause an interference, and sometimes it's doing very, very bad. Sometimes you can control the interference because you need this overlapping some way or another, but you have to control it. So this detection can be done using some information from the network, and the machine learning can identify if this overlap is already exists, or it will be happen in the future according to the activity that you are doing with the network, the change of the behavior of the customers, and so on. So you can use the artificial intelligence here in brief to identify the overlap in your network, and the bad overlaps, if I can say. Data hotspots, and you can do a lot of traffic profiling. For example, if you are staying in Toronto right now, and you are in the middle of the downtown, and you can have like a time map for all the location inside the downtown, how much or when and where you will have a very part of consumption for the data traffic, and can consume, or you can design your resource according to this time map or time space map, if I can say. So this is for the hotspots. For the throughput geolocation, you can even identify the download speed, and according to this location, you can see that most of the people in this location have a very high demand for the download, and but unfortunately they are not equal in the speed, because they have a lot of overlaps. And as I told you, you have a lack of dominance in this area. So you have to make sure that this high or very demanding area for that throughput, you have to design your network according to it. It's a very, very normal classical clustering use case. And also for the code failure analysis, you can identify where the failures happen, where the drops happen, and you can use the causality and the root code analysis for the troubleshooting to know if it's correlated to some places. Maybe it's like on a tunnel, for example, or maybe it's something that's related to the traffic that consume most of the coverage in this area, and it can cause a very bad quality issues for the customer. So this is a geolocation. They are not just useful, but is part of the geolocation use cases. Next slide, please. And it's very, very another one, which is called self-healing. It is a thing that Abdul Rahman was talking about it at the beginning. It is mainly how you can let the machine or the machine learning model listen to all the alarm of the network, and then once there is a problem happen or a downside happen, and if this site was down by power, maybe it's power outage, or maybe the batteries have something of that, or have a failure, the machine identify this triggered with this action or with this alarm, and then automatically it will do an on-site learning of how this location impacted by the coverage, and then it will calculate automatically the best neighbors for this downside to do some mitigation action according to the learning that the machine have been gone through in the past. So it will understand that this site, for example, site A and site B, they can cover 30% of the coverage from site X, and site B can 20% of the coverage from site X. So they can, with some stretching for the tilt and the parameter settings, it can mitigate or can collect most of this dropped traffic from the downside site X, and it can done automatically, and it can be restored automatically after the site X back on air. And you can see the difference here from the next slide and this slide. So you can see here that one side down, X is down, side A and side B extend their coverage to cover this gap and this coverage coverage gap. So next slide. So this is another use case, very useful, because it's merging the augmented reality with artificial intelligence. So in the past, when you are doing a coverage scanning, or you are trying to build a new site in some area, you have to send someone that he can do scanning and acquisition activity to check where to put the new site and what is which is called drive test or field planning engineer, or even office planning engineer, and he do this kind of scanning and he send it to his colleague in the office, and they are doing analysis and putting a lot of simulation on the tools, and then they choose the place to put the site. But and accordingly, sometimes they build a new simulations tool that can predict where to put it from the office. But this unique use case was very nice, that we send the guys with a tablet, and he can just move the tablet on 360 to get a 360 picture for all 360 picture for scanning for this point or this location that we want to insert the new site. And automatically when he choose a location to put the site with the type of antennas and the type of the sector and the height, it can automatically run this model to predict how the site will act with the neighbors and where the gaps will be. And it will be very easy for him to say or to predict the efficiency of the location of this site automatically, and it's automatically connected to the another engineer at the office. And it was very unique, and it was very new idea that built up with our engineers, and it helped to accelerate this site selection or site identification processes, even with a higher quality. So it's one single site visit, on the site coverage check, and real time ready simulation. Next slide, please. It's another one related to the power backup system. And as you see that I'm talking about a different topic into the telecom. Maybe something in the power, something in the optimization, another something with the planning. But this is to show you how much the data or diversity of the data that we have in the telco. So you can consider the telco as not only one company, but a different countries, different companies with a different data type and different topics. In this use case here, in the power backup system, you can use the machine learning to do the balancing for battery at the same level with discharging. So, I'm not an expert in the power engineer, but according to my colleagues' stories, when you are doing this kind of discharge, site right now is down, for example, and it work on the reserved power battery or power backup. So it consume one battery string by another, and one by one, then it's go to empty. So this kind of discharging sometimes is not fair for all the batteries strings, and it due to the pattern of the logic at the second step, as you can see, the charging logic of the batteries, it sometimes prolong some battery life over the life of the other one. If you keep the battery always charged without any discharging, sometimes it's harm the battery and shorten the battery lifetime. So you have to do this kind of synchronization and this kind of equal distribution for the discharging according to strings. And this is how you can use the machine learning to identify with some prediction, for example, for the time how much the battery will be down. So you have to predict from the history how much the battery are working on or the site working on a backup system. Or even you can identify from how much this battery have been charged and discharged. You can predict when you need to replace this battery with a new one. And before it's damaged, and you can have a failure on a system failure or system feedback. On the anti-theft system, we also build up something that's called the clustering system for the batteries, and where you can make these batteries identified only in our system. So if someone stole this battery and try to use it in another way, the battery will be deadlocked and it will not work. It have to be worked inside our system. The other one is balancing the battery at extreme low loading. So it is related to the same one, how you can balance but only on the low loading system. So if you right now at the downtime, maybe you will need to just activate your your battery system, because you need you can consider that, for example, if you left all the batteries fully charged for 2 years or 3 years without any discharging, because there is no need for that, the power is up and everything is good, it's kill also the battery. So you have to make the battery memory always active and for the recharging and discharging. So you can do this using the machine learning automatically at the downtime or the off peak or the down traffic or the low traffic period, to do some activation for the batteries, even for just even to prolong the lifetime of the battery. Next slide, please. It's got the other two that the other one is called predictive maintenance use case, and here it's from the name you can know it's very obvious for you to know that that's how you can study the main aim to convert the alarm fixation process from a reactive mode into a proactive model. So using the machine learning and data mining and so on, and using the alarm history per site, per each and every site, you can predict the future alarm. Sometimes the alarm, sometimes not all the time, happen with a pattern. So you have alarm X, alarm Y, and then you have an alarm Z. If you can identify this pattern, you can know that alarm Z is upcoming, and you have to take care of this alarm Z. Maybe it have a higher severity and so on. So it's predictive maintenance use case, and it's mainly depending on the alarm generated by the sites. The NPS prediction, or the net promoter score prediction, with some feature you can identify if the one that he will call you right now on the call center to report or record an issue in his line, for example, or his SIM card product that he is using right now. You can predict from his line and the activity that he did on it. If you have some drop calls, for example, they have some loss coverage. You can see, or you can predict if he is a detractor or passive or a promoter guy for you as an operator. And even if you didn't call him, and if he didn't call you, from the family and this kind of clustering, you can identify how much of your customer are promoters, how much of your customer are detractors, and how much of the passive are passive. And even you can put it within geolocation information, and you can find the weak areas in your network. And this is how we do it inside Vodafone right now. Next slide, please. That's the physical cell identifier, or any cell identifier, or a frequency reuse. So it's a planning tool that you can use it to redo the planning for the 4G PCI, or even for the 5G, the 2G, and the 3G, for sure PCCH and scrambled code, for example. So you know that when each and every site you have to put some identifier for this site, which will be the identity for the site for the handsets to camp on it and do the calls and activity on it. And you cannot reuse. You have to reuse this resource, which is here the PCI, for example, for the 5G, without doing this kind of near site reusage, so you can harm the performance of the customer. So in this tool, it can generate and predict the interference matrix between each and every site, and then it can plan the PCI accordingly, so it can put the optimum usage for these valuable resources without harming the performance. And the lower one is the multi-rack coordinate energy saving. And here you can see that in this coordination, it can be used to utilize and prolong the battery lifetime of the site during the commercial power cut. This increase the network service availability with a minimum performance impact. And to give you more small details about this area, this, each and every site has a different radio access technology, which is called PAT. The 2G, the 3G, the 4G, the 2G over 900 megahertz, for example, or we have an also LTE or 4G on the same 900 megahertz. And this different technology, sometimes you can use the machine learning to sacrifice some of this technology if you have a down time to prolong the time that you are using the battery on it. And you can see here, this is one of our best practice. For example, we prolong the site for an extra 80 minutes to work, and then same battery dimensioning with the same battery capacity. We're just turning off some of the technologies. So this is mainly the briefing of what is written here, and I hope it's clear right now for all of you. And you can ask me if you have a question for that as well. Abdul, I don't know if Abdul have recording some questions on, but I will try to answer every and each question after we finish the slides. Next slide, please. Interference classifier, which is very, very nice work of our engineers inside Vodafone. It's how you can identify the type of the interference from the pattern of the interference. Using the machine learning, we can code it like an X-ray scanner for the interference. You just put, or you can just have this kind of snap for the interference for example, spectrum analyzer, and then the machine learning do this kind of scanning, and it can give you, this is like an external interference. This is the positive intermediate PIM interference, or passive interference from the system itself, or it's something that you can. This is a notch, something came from the cable, for example, that a use case that we find in Germany. Sometimes the TV cables impact the system or impact the spectrum some way or another. So this classifier, excuse me, is very, very nice, and you can easily describe it as an X-ray for the spectrum to identify which is the part of the spectrum that have been hit by the interference, and what is the type of interference as well. On the other side, you can the lower one, you can check the network performance management, and here you can see it's a replicate for the normal troubleshooting on the side. If you have a daily check, for example, or a daily monitoring check for your network, you have to let your engineer to grab the data and they add analysis, and then they are doing this best practice. So if you have an engineer that's very, very good, and you have a newer one who's a newcomer that he need to learn more about the network, if you have to split this kind of activity, or some engineer that he have, or some of the engineers that they have already experienced, so they can analyze and do the troubleshooting. Using this NPM, you are here replacing this activity from human into machine, and then you can just leave the human at the end, identify the output to clarify, to double check and check if it's really coherent or not, and you can even use the output of this human or the engineer to do the reinforcement learning work for this model. Next slide, please. Smart CapEx, and this is a very, very famous smart CapEx use case that you can find it in, and I know that Rahman is smiling right now because this is our famous Telcom use case, smart CapEx right now. So CapEx stands for the capital assets for the network, or capital expenses, sorry. And our capital expenses is how we spend to build up new sites. So where to put the new site, and how it will impact your investment, and where is the best place to allocate the size to clarify or to fulfill customer requirement with a better with an efficient investment, and so on. This kind of use cases is called, I can solve it like a multiple dimensional complex use cases. You have a lot of features from different domains: customer experience, NPS, for example, payment, revenue, coverage, KPIs, parameters, and so on, and you combine everything together on a map, or for example on a visualization tool, and then you can give you a multiple choices and multiple scenarios for the decision maker to do the investment with this scenario or this scenario or this scenario, and what is be the problem if you use this one and this one and this one, and give you a very, very solid, accurate, or more accurate decision, rather than using just your calculation and your experience. This is a very, very good one, and you can find it with a different definition, but this is a common definition for the smart CapEx overall the telcos. The lower one is called the TX KPI correlator. Here, when you can, TX is standing for the transport or the transport network, and you can, for example, if you have different system, the network here in the telco is built up on three main pillars, which is the radio access network part, the transport part, and the core network part. And each and every part here have its own metric and have its own key performance indicators. And so it's very, very important you write the machine learning to make this kind of correlation between the KPIs and the different aspects, because at the old days, most of the time they are isolated silos. So right now with the machine learning, we can do this kind of correlation, huge data from here and huge data from there, and we can combine them, and then we have some correlation between the KPIs here, so we can do a lot of prediction, and you can do a lot of better dimensioning for each and every silo, if you can say. Next slide, please. Traffic modeling and prediction use case. So in this is you can see here how much the capacity that you are trying to absorb in the next in the next upcoming years. In this use case, you can work on many prediction and regression models to able to predict the network states in the future from the traffic point of view. For better decision making, and for example for the investment and so on, and even for the translate this kind of activity into resource utilization, which will be impact the user throughput at the end. The lower one is called applying power control using the unsupervised machine learning. It's very, very long, but it's applying computer use the machine learning, applying power control. And you know, the power control is an algorithm that have been always used by the vendors with a very rule-based old legacy algorithm. Right now, and the power control is in a brief, because if you are not familiar with it, it is about how the base station is acting toward the handset when you are moving away and near to the site. So if you move away from the site, this algorithm activated that we are moving away, and I have to increase the power between you and me in this session. And if I came near to the site, this site have been to be lower down, for example, the power, so it can improve the interface in this area. And this power control was just, as I told you, was managed with a rule-based algorithm. Right now, we can use the machine learning, or we already use the machine learning to identify the best setting for each and every cluster of sites. So if you have site with this feature, you can put these parameter settings. And on the other side, if you have another cluster that's called cluster B, for example, that have another features, another characteristic, you can use another power control setting on it. So it's a classical clustering use case. Next slide, please. Alarm compression and pattern recognition. Here in the network, each and every network is generating 1 million of alarms. Like the self-healing, for example, one I was talking we are just tackling the downside. So each and every month, majority of these alarms are trivial or correlated with another alarm. With with the same root cause analysis, which is wasting a lot of effort and time for the people to chase this kind of correlation, because it's very easy to be identified by the machine. By using the association rules, we can detect all the dependency between the network alarm and even with the KPIs, and accordingly reduce the number of trouble tickets from the NOC point of view or the service operation center, which will directly impact operational efficiency for the network or the telecom. The lower one is called TTE correlation, or the trouble ticket correlation and dependency mining, which is somehow related to the other one. Right now, we can identify the alarm correlation and dependency logic to be defined by our engineer or by the machine, and so you can. The remaining potential use cases are extremely hard to be spotted, because not all the alarms is always correlated. Sometimes you have something sorry about that, but problems sometimes just happen. It's not something related to something, that it's something incidentally that you can never predict it. It's happen, and it's always, it will be happening with this unknown prediction. But for the other pattern, or the something that we can solve, that predictable alarms, we right now can correlated the trouble tickets together to know that this trouble tickets is a family trouble ticket, so it happened with this sequence, and we can help, for example, even to reduce the manpower in the SOC, as well as it can prevent the failures of the site and so on. Next slide, please. So right now we are leading in something called 5G on the future networks, which is managed by the ITU, which is International Telecom Union. International Telecom Union, the ITU, is a part of the United Nations, and it's concerned about how to manage the spectrum between the telecommunication ecosystem between the countries. Right, and they have a lot of focus groups, right? Not just one, but they have 100 focus groups, maybe, I don't know, but not 100, maybe a tenth of some of them. But this focus group is mainly related to the machine learning and the future network, and the 5G and future networks. We already working there, and it was launched in 2017, and we already launched and it's divided into three pillars. The first one is called use cases, and then you have the data science, or the data analytics, data engineer part, and the other one, it's called the network architecture. So we are doing the gap analysis in this study group to identify how we can implement or insert the machine learning units inside the network with the best standard and protocol. Next slide, please. The same happen with the AISC, which is the European standard body, the famous one. We have another one is called Experimental Network Intelligence. We are leading in this part as well with our colleagues in Telefonica, Telecom, Italia Telecom, or something like that, and also from other vendors like Ericsson, Nokia, Huawei, and so on. And it is the same thing, but we are using a cognitive network management architect using the artificial intelligence and context-aware policies to adjust the offered service based on the change in the user needs. So it's adjustable according to the needs in the user behavior, beside the environmental condition and the business goals. So this is another initiative globally that we are working in with the global community worldwide for the better usage of the artificial intelligence inside the telecom. Next slide, please. So right now I finished, and I took a lot of time. Sorry for that, Abdul, but I hope that we can catch some of these questions if you are writing something or you have something that.
For sure.
Back to you.
Yeah, thanks a lot, Mostafa. I mean, that was a really interesting presentation, and I mean, like, really informative, actually. And I mean, you covered a lot of use cases that are, I mean, and a whole spectrum of use cases that telco is leveraging AI and machine learning for. So I found it really informative, and with 5G and IoT. Like, telco can leverage AI and machine learning for all this, for all these use cases. And I think, like, I really like the phrase that you used, that telco is the bank of data, and it can use AI and machine learning to its advantage for some of these this really exciting business use cases, essentially.
Yeah,
So I think from I'll move on to questions. So in the audience, I think there was some interest basically in natural language processing, and how natural language processing is used in telecom. And I think, like, that you had a slide in one of your initial slides. You actually had natural language processing over there as well. So can you actually comment as to how Vodafone, let's say, is using natural language processing for some of its use cases?
Yes, sure. It's not too much, to be honest, in the telco for the NLP, but however, we can use it in two main assets inside Vodafone or even outside Vodafone. From my work with the ITU, with other guys from T-Mobile, for example, and so on, the different companies. We can use it in the chatbot, for example. If you have a chatbot that can be your first line of defense for the customer care, using the NLP will be much good. and you can train each and every model according to the location and the language for sure. And even if you have a different language, for example, we are in UK and you have in US, for example, and you have in Canada, maybe all these guys are talking English, but they are not the same data set that you can train your model in it. So an LMB can be used in chatbot as well as can be used in the data analytics from the social media and Facebook and Instagram and this kind of comments. You can identify how much of these comments are positive and negative according to the sentiment analysis of this text and so on. So this is maybe the most correlated use cases to the LMP in telco from my point of view. Maybe you can find something else, but this is two major things that we can talk about it today.
Okay, I think there's also a follow-up question from the Mostafa. Can you hear me?
Yeah, I can hear you.
Yeah, so I think there's also a follow-up question on collaboration basically. So I think like we can I mean like I can just ask a general question over there, that does Vodafone basically work with external entities for AI and machine learning and collaborate with them, and like can you comment on that essentially?
Yeah, we are always open. Yes, we are always open. We are already doing a lot of things. We have a lot of activity, and you can see that we are working. Mainly, it depends on how we can get leverage from a win-win situation. So if this external entity would get some benefit and Vodafone can get some benefit, we can have a deal for the thing. For example, we worked, for example, for a while. I or myself worked with the University of Berkeley in California to some studies and so on. So it was a mutual benefit activity under the GSMA umbrella, right now. So we can, yes, we always have a way to collaborate. We always have a way to work. However, sometimes from my experience, that some people would like to ask to take some data to work on it, and to get the data out of the customer from the telco, you have to do a lot of procedures to make sure, or to even prove to the government or to the regulator in each and every country that you are not you are misuse this kind of data, or you're exposing it at customer data, you are exposing the privacy of your customer and so on. So it's not always very easy to do it. However, if we take the countermeasurement, if I can say, or the measurement that we can avoid any of these risks from the beginning, we can easily collaborate with different channels and then different entities. Yes, for sure.
For sure, yeah. No, I think there's another question. Let me just some of the. So the question says most of these use cases has been implemented with AI in-house solutions from or vendor based. How do you see the landscape from AR market tools to put them in the business directly?
It's only one for the AR, yes, and it's not too much, to be honest, and it's very novel from our guys, our friends from Italy. I think the AR is it was an AR, right? Or I'm answering
No,
a lot.
so I think I'll ask the question again. So most of the use cases has been implemented with AI in-house solutions
Okay.
or vendor based. How do you see the landscape from the AI market tools to put them in the business directly?
Okay, so if I understand the question in the right sequence or the right context, yes, most of these use cases are being built inside Vodafone, to be honest. Not with the vendors. All these, maybe 90% or 95% of these use cases built up with our engineers. Why that? Because a lot of things. The first one, you have to build up these use cases with someone that you have two pillars to stand on. You have to get the business expert, the radio engineer, the core network engineer, and the transport engineer, the security engineer, and you have to make them engage with the data analytics and data science, or even the software engineering guys. And this kind of collaboration, it's much better to be in the same environment, in the same location, which can facilitate a lot of things. They have the common goals, they have the common strategy, they have the common language. It's not a vendor customer relationship. It is a colleague relationship. However, sometimes you can lose some opportunity if you didn't talk to the customer, to the vendors. So you have to always check with the vendors if they have something that can give us something an extra value. You have to work with them, and you can find a way that it is the same thing, that you cannot work with the vendors. You have an NDAs and so on, but you are talking right now with the data of the people, and this is something very, very hot. You have the GDPR, for example, in Europe. You have a lot of rules in US. I don't know what is going right now in Canada, but I think it will be the same. All the countries worldwide are talking about the privacy and security, how you can keep your customer data safe without any manipulation, without any usage, without their permission. So this is some of the challenges that sometimes you can face when you are trying to develop something without your outside of your entity, with a vendor or even with an academical or lab or something like that. So how much this impact the product, it much impact very, 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 very badly, to be honest, because when you have two minds, you are missing a lot of things. If you have a 5 minds, which is a vendor, for example, you have a better result, and you have a 100 minds, for example, you have a better results. But sometimes the use cases and the rules govern all of us, so we have to abide with it. We have to get respect, to keep our respect with our customers. So you are an engineer, for example, now, but at the same time you are a customer. You don't like your data to be exposed for some commercial usage or something like that from a different third party without your permission. So this is mainly the main challenges for scaling up the artificial intelligence usage inside the telco. However, as I told you, we have always a lot of workarounds without exposing or doing any vulnerabilities on our customer data.
Yeah. No, that does ring a bell, actually, Mostafa. I mean, like even at TELUS right now, I'm like we are pretty big on PIA and privacy assessments, and I know that even when we are talking about the cloud, like, I mean, this is a big thing that should like, are we basically sending the customer data? I mean, are we sending the data basically in, like, are we taking care of privacy when we are moving the data to the cloud? So these are some big discussions, and I sort of like see them on a day-to-day basis, actually. So yeah, that does.
You're
like,
right. I will just interrupt you to give you how much the problem is diverted right now inside the world. For example, you have some countries like Germany, like Egypt, like Turkey, and these countries are not allowing to let their data out to be outside of the territory itself. So, for example, for Vodafone right now, we have a different countries that we cannot put their data inside the cloud. This is something that can let you miss a lot of opportunities, because
Yeah.
you cannot. They are on islands. However, you have to to be respectful to this regulation, and it's rules. So you have to abide with it. You cannot say that no, I want to collect everything, because each and every country have the freedom to protect the data of their citizens. So this is very, very hard, to be honest, to deal with. However, as you know, that all the challenges in the human life always reflected, or we have a lot of proactive action or reactive action to solve these challenges with different very innovative ideas, and I believe that it will be raised that can compromise this kind of compromisation between keep the privacy good and safe, as well as can reuse the data on our scale.
For sure. Yeah. No, that makes sense. So I don't see. So I have a few questions that I prepared as well. So perhaps I can start with the technical questions. So I guess I can move your slide, like, let's say, to the predictive maintenance use case. I think like there was predictive maintenance. Yeah. So over here for the predictive maintenance use case, I was curious, like, do you actually have your like a model per site, or do you actually basically like cluster do some sort of like clustering of sites based on behavior, and then sort of like normalize your machine learning models across that cluster? Like what approach do you take over here?
just like what you said, it's a clustering model. So we are doing it's unsupervised. So it's a classes. Sorry, it's not a classes. It's just a clusters. So the machine here creates, for example, 5 bags of type or 5 types of sites, and then it can distribute all the sites in these bags according to the behavior that it acts from the part of the alarm generated by the site, the alarm history. So according to this alarm site, it can be in family A or family B or family C or from family D, and it can transform from one family to another. And these families, they have sometimes, as right now, we have a what can I say, like kind of catalog for the proactive of predictive maintenance. For example, cell A or family A, it is a very high severe family, so you have to do daily, for example, PMs for this site on this location. Family C is very normal thing, so you can do it each and every month, for example, and so on. So according to the type of this site and where this site have been inserted, according to the clustering model, you can work accordingly. So I think that you ask the question, you answer it at the same time. So you are right. Yes, you are right.
Yeah. All right, thanks a lot, Mostafa. So I'm also curious about like edge computing. So for instance, if I go to the multi-rat use case over here, I think like you actually had the multi-rat use case. Yeah. So over here, like for this multi-rat use case, I mean, would this be something that's actually like running on the edge, or is the data basically going to the core, and then the modeling and the inferencing is happening at the core? How does that work?
What you are talking about here is our next step to do this kind of edge computing for this use case and different other use cases. But right now, to be honest, this use case is done all in the core. So it's a centralized model. It's not an edge model. It collect all the data from the operational the operating system or managing operating system for the power. So it calculate all the information about the power from the core part, and then do analytics at the center or the core part, and then it act even the scripts and this kind of activation and deactivation from the center, not from the edge.
Okay.
Putting it at the edge will give us a better resolution for the time and even for the analytics. However, we have to insert some edge computing, physical computing or physical resource computing inside the edge. Maybe not at the terminal side, but maybe at POC 1 or POC 2, which is the point of connection for this one site. So we can have hub sites that have an edge computing, which can serve all the other of the three of this connectivity of this site.
Yes, and with 5G, like, do you see like some of this actually like shifting to MEC and some of the use cases and models being like running inside the MEC itself?
Yes, sure. 5G is the gateway for the speed, and gateway for all the new exploration for very high dense, high speed, high dense connectivity. So edge computing will be in another era after the 5G have been rolled out worldwide, because it is a core, or it is the soul of the mobile edge computing, to have this kind of fast connectivity, or even a huge dense connectivity for the capacity point of view. So the 5G will be the the live key for the mobile edge computing. Yes, for this use case on different. Yes.
And I think even the machine learning paradigms would change, right? Because right now, when you do modeling, the data comes in, you actually have like one model, like one monolith model, basically, like that's sort of doing the crunching and doing the inferencing. But I think like perhaps like when you move to the edge, you'd have to look into like more into splitting up those models, and perhaps like look into federated machine learning approaches and distributed AI. And I think like those paradigms would become more relevant when we sort of split up things between the edge and between the core, right?
Totally agree. Yes, totally agree. Federated learning, and even this kind of learning model in the sandbox, and let's send it to the edge to do the the inherence or the inference or even the correlation part or the comparison part. 5G, as you said at the beginning, it will be a kind of game changer for all these kind of technologies, starting from the mobile edge computing, even AR and VR, and as well as it should maybe hitting the gaming and so on, and as well as you said here, federated learning. We can do this kind of federation according to your model to send it to be distributed in different places, and you can do this kind of learning in a different places, not only a centralized place.
Yeah. So I guess perhaps I had like one more technical question regarding, I think there was a. Yeah, so the traffic modeling. I had a question around here. Like, what sort of models or like statistical models or machine learning models did you use for traffic modeling? Because I see that this is a modeling in time, right? So what were the models that you experimented with, and what was the model that you finally used basically for this traffic modeling and forecasting use case?
Yes, for sure. We are using different models. Sometimes we have to do a lot of trial and error to find the best model to be used. For example, we use an LSTM, for example, time series analysis and so on. All this kind of family that can you include the time trend in your learning. You have to try it, and then you can do a comparison between each and every model to find the most optimal one that you use for. But to be honest, the key success of this use case is how you can do the profiling for each and every site. And profiling here, I'm talking about where the site is working normally, and where the site period, which is called the seasonal period for this site, for example, or something that happened. It's not a normal trend. And if you can differentiate between this kind of two condition or status for the site, if it's a normal trend or it's a seasonal trend, you can easily predict for the future. Or you can identify using any other model. You can predict even if this site is going up for the traffic, or it's a decaying site, so it's going down. The traffic is going down, or it's something that is very very stable. So if you can do some, it's not a data cleansing, but it's something that it's called feature engineering or feature cleansing, to remove the seasonality from each and every site. It will improve your use case or the product, whatever model you are using. Yeah, for example, LSTM and so on. So for prediction, it's for the time, so you have to use the time series analysis and so on. This kind of family will be the most optimal model for this use case.
Thank you, Mostafa. So I think I actually have like one last question on data silos basically. And since you are a leader in AI and machine learning at Vodafone, I thought I'd pick your brain on this. So one problem that I see essentially with telcos and with large corporations is like how siloed most of this data science effort and most of this data engineering effort is essentially, right? Like it seems that most of these teams are essentially doing the same thing and wasting efforts rather than doing them under a single umbrella. So is this something that you also see at Vodafone as well? Like do you have like data silos at Vodafone? And I mean, if yes, like then how how is Vodafone trying to solve that problem?
Yes, it is the normal, because right now each and every guy from you are coming from the past right now. Most of the team think that if this data has been generated by myself or my tools or my hardware, so it's my own data and I have to use it. But sharing the data, sharing the insights was not always good at the beginning in all the country, in all the companies, according to my knowledge. But what we did in Vodafone, we have a lot of strategy to be revamped, and it's very very have a very very good impact right now. How to correlate these silos together, how we can find this kind of common ground to build up a new strategy that can contain all these silos in with a common vision, so they can work distributedly. So you should not work only. For example, as I told you, have a constraint to make all these silos connected to one cloud or one ocean, for example, or something like that. But this is not the optimum thing, because right now, as I told you, some countries are away. Not all you cannot connect. You have to invest a lot of money for the firewalls and connectivity between each and every data center, for example, and so on. So sometimes you have to train your people for the culture, how they can use, or they are collaborate. They are collaboratively using the different data, or the different data between them and their colleagues, which will be much better than investing millions of connecting everything on everything, and build up very, very huge cloud that can contain everything, and then you can control, because you have only one entity that you can lead the data used by the science. And this is so. To be honest, I saw a lot of solutions that have been done by different companies. For example, as I told you, this collecting only all in one cloud, for example, or managing every data, all the data with only one entity. But this is not the optimum thing, but it's a very easy thing to be done, because you are just let someone with the one authority to do it. However, it's not easy for the implementing, because it maybe cost a lot of money, and maybe you have some obstacles that you cannot even solve because of this kind of different countries that maybe planning to send the data outside of it. So on the other side, you have to build up a better culture. And this is what we did in Vodafone, and it give us it pay back us very, very, very good, and we are trying to be, and I believe that we are working very, very good in this point of view. So the culture is much better than, or investing in the culture is much better than investing in the computing and processing.
Yeah, that makes sense, Mostafa. Thank you. So I think from now we can, we'll just I think it's almost time. So Mostafa, thanks for taking the time from your busy schedule to present at ACE and share some of your work on AI and machine learning with us. It was a great presentation, and I personally enjoyed it a lot.
Thank you very much.
And we look forward to having you again in the future at some point as well. Thank you, Mostafa. And for our audience, I'd like to thank you all who joined and who listened to this presentation. For more content like this, please subscribe to our YouTube channel, ML Explained AI Socratic Circles ACE, and check out our website, ai.science. Thank you all.